When you know what type of confidence interval you're looking for, you can go ahead and plan ahead of time what is the minimum sample size that you're going to need. Now, in order to do this, we're going to start with the confidence interval equation that we had earlier. And working from that, we're going to look at the part that is the standard error. This part right here, the plus or minus, or the part after the plus or minus, is how much error there is in either direction from our original guess of x bar. So we're going to take that part aside, set it equal to SE, the standard error, which is also called the margin of error. And since we want to solve it for n, the sample size, we're going to go ahead and multiply both sides by the square root of n and divide both sides by standard error, so we end up with this equation right here. And then finally, in order to get n by itself in its first power form, we need to square both sides. So we square both sides here, and then we have the whole thing equal to n. So this equation down here, z star times the standard deviation, all divided by standard error, all squared, is going to be how we predict our sample size. And just as we've done in the past, whenever we're calculating a sample size, minimum sample size, we're always going to round up, because if we round down, we're going to end up getting a little bit more error than what we said was the most error we can tolerate. So we're always going to round our estimate of this value up. So here's a quick example. We're given a problem where we have an average of 2178. You'll notice that the average shows up nowhere in this equation. And in fact, the average doesn't matter. It's only the standard deviation that matters here. So this 120 value that we know is what we're going to use. We want to make our margin of error based on a 95% confidence interval. So we're going to use the z star that is based on 95%, so 1.96. And the maximum standard error, SE, is going to be equal to 30. So if we piece this all together here, we're going to have our z star 1.96 times our expected standard deviation of 120, and that's all going to be divided by the standard error, the maximum standard error, which would be 30 in this case. And then we're going to square the whole thing. That squaring is very important. So we have 1.96 times 120 divided by 30, and then we'll square that whole answer right there. We get 61.4 something. And because it's the sample size that we're predicting here, we're going to always round up. Minimum sample size, we're going to always round up. So we're going to call it 62. So in order to collect data for this problem, in order to get the margin of error to be the size it needs to be, we're going to need to collect data from at least 62 people. One more quick example. Again, we're given x bar in this example, but typically we're not going to know that ahead of time anyways, and second of all, it doesn't show up anywhere in this equation, so it's not something we need to know. But it says we want to predict with 99% confidence, so that would mean we're going to use the z star 2.576. We have a maximum standard error of 2, SE is 2, and we have a standard deviation of 9. So when we put that all in the equation together, we're going to have 2.576, excuse my 2 there, times our standard deviation of 9 up in the numerator, all divided by our standard error of 2. And we're going to take all that, we're going to square it, and let's do that. 2.576 times 9 divided by 2. Square all of that. And if we round up that answer, it's going to give us 135. So our minimum sample size in order to get a margin of error less than 2, when we're predicting with 99% confidence, it's going to be 135 people. And that's calculating sample size.